Recording in progress. Good. Now, let us continue, my friends. So the site planning and construction is 8 months. 8 months. Here is the life cycle of a well. Then the drilling, maybe 1 month. Then maybe the hydraulic fracturing for 5 days. Then the production, as I told you, between 20 to 30 years. 20 to 30 years. This one. You see, here is the fracture. We will talk about it. Now, the 3D seismic, as I mentioned, it is one of the most important techniques to help geologists and engineers. Why? To find out where possible. You see, possible. We are not sure. Possible hydrocarbon is below thousands of feet, maybe 10,000 feet below the Earth's surface. Without a 3D seismic technology, many oil fields cannot be discovered. As I told you, we have 2D, 3D, 4D. 4D is the most advanced technology for the seismic survey. The geoscientists have a secret weapon called seismic exploration. And it involves, what does it involve? Sending acoustic or sonic energy, which takes the form of wavelets, the layers downhole, into the ground to get a sound picture beneath the surface. Geoscientists use man-made tools to make the sound, wavelets. Listen to them and then record them. I will show you the map now. When you want to know if oil and gas deposits are in a particular area, geophysical companies bring large trucks that have big vibrators. You see, vibrators, it can vibrate the earth on them. Most of the time, this is what generates the acoustic or sonic energy or a vibration. They use geophones. The geophone will be the receiver. Geophones or hydrophones in the offshore. In the sea, we use hydrophones. In the onshore, on the land, we use geophones. Or very sensitive seismic microphones. You see, it can receive the sonic waves to hear the reflected sounds, but sometimes they set off small buried chars. Sometimes we put very small chars or explosives. Instead of vibrating with a huge machine, we use maybe explosion, maybe small, very small, maybe 5 grams or like this. It doesn't affect, and it is allowed in our industry. So they set many geophones or receivers. We call them receivers on the ground on the other side in a line, and they are attached. We attach these geophones to recorder. Inside another truck. So one truck for sending waves and one truck is connected with the geophones, like listeners. The vibrators send thousands of wavelets down into all the different layers of the earth. Some of the wavelets bounce off we have either reflection like this is reflection. Look at me. Or we have refraction. What do you mean refraction? Look at me, please. This, then it moves on the surface of the layer, then it will go up. We call this one refraction, inkisar. Some of the wavelets bounce off the boundaries between the rocks below the surface and are reflected. You see, reflected back to the geophones that are waiting to record them. So record them. Each geophone we have sending time and receiving time. So we have delta T between these two. We can take it and we can draw the map underground. And each geophone along the cable sends the received wavelets to the recording truck where they are recorded and stored. Then we can, what you see, this is what do you call this one? Reflected. This is reflected. reflected, all of them. So we can have like this layer, like a reservoir, for example. Here, if we have not like this one, if we have like a straight, then it will come from here, then like this, then we call it this one refraction. Refraction, not reflection, refraction, inkisar. So these we have here, you see either vibrator, we call it vibrator track, or we have, what do we call it, like small explosions, explosives, we call them. Then it will reflect to the geophones, you see, recording channels or geophones, we call it. All of them are connecting to the recording track, recorder, we call it. So this one will tell you that we may have maybe the possibility. Everything is possibility. What does it ensure that 100% the drilling? Without the drilling, we are not sure. Here we have offshore. You see, we have source of shock waves. We could use air guns, not explosives. What you imagine? No, air guns. It will generate the air guns, the air waves. You see, waves, and it will reflect. You see, reflect to the hydrophones. We call this one not geophones, hydrophones. You see, these. Now, I want just to tell you about the IWCF that it is not allowed for any one in respected companies. In your company, in your country, it is very respected. I gave them last month course, and they are at very high level. So they don't allow you to work if you don't have this well-controlled certificate. We have two types of certificates, either British, we call it IWCF, International Well Control Forum, IWCF certificate, or IADC. IADC, it is American, in Texas. This IWCF in Scotland, in UK. And the other one is IADC, International Association of Drilling Contractors. That is in Texas, in America. Some companies, they accept this one. Some companies accept this one. So both of them are well-controlled certificates, but they say that the British certificate is stronger than the other one. But both of them are okay. There is no, because they give the same principles, the same procedure, same equipment, same everything. But somebody is preferring this certificate, somebody is preferring this. So it is, and I am certified for all modules, surface and subsea, drilling and well intervention, wireline, coiled tubing, snubbing, all of them. You see, here we have mandatory and we have levels 1, 2, 3, 4. And this is sample, you see sample of IWCF, for example. I do it for me every 2 years for all modules. You see wireline snubbing and coiled tubing, for example, because the instructor should also make refresh for his knowledge. Otherwise, when we say that we know everything, in this case, this is disaster. So you have to refresh your knowledge and you have to know new information about the oil and gas industry. So this is for the well intervention. The other one is for the drilling. You see, the drilling. The drilling, you must, here, as I told you, you should know these are mandatory. Completion equipment and completion operation. I expect that all of you will take either IWCF or IADC soon when you get graduated. So here, this and this are mandatory. You have to do them, this and this. You can add either wireline, if you are working in wireline, or coiled tubing, or snubbing, or maybe mix this and this, plus mandatory, this and this. You can, if you are working in snubbing only, you can use snubbing plus this and this. So whatever you have the freedom in this case. For the drilling, we have principles and procedures, equipment and simulator. Principles and procedures, equipment and simulator. Simulator is not that much difficult, but you need training. You need training to know the principles of it and how do you work on it. Because you will utilize it as if you are drilling or you are killing the well, or same as the pilot. They don't allow the pilot to go straight away to the aeroplane. They have to train him first on the simulator, same as the simulator, but different principle. Then they can allow him to go to the practical. Also for us, the same. This is also, you see, this is sample also. They say that, for example, surface BOP stack. We have surface, we use it in the onshore, and we have subsea stack, BOP stack. We use it in the offshore. So just take an idea now. When in the future, when you need it, well, then you can go through it. Also, we have levels 1, 2, 3, 4. There are two types of stacks. We have surface and subsea. For the well control calculations, you have to know all of these, and I am sure you know all of them. But just for refresh, I put them here. Please look at them. If you have any gap in them, you have to fill this gap, because these are like alphabet for you as a petroleum engineer. You have to know all the hydrostatic pressure, bottom hole pressure, reservoir, specific gravity, etc., 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 the capacities. And I am sure all of you are very brilliant in these calculations. But I put them just to ensure that you are practicing them. Now let us move on to the drilling rigs. What is the definition of the drilling rig? It is an integrated system. Last or 10 days ago, I just came back from Abu Dhabi. I delivered a course, we call it rig inspection, rig inspection and audit. Rig inspection and audit. I delivered it to 8 engineers. The month before, I delivered it to 11 engineers. So it is very important. Every month, the companies require to do rig inspection and audit. So what is the drilling rig? We inspect every single piece in the rig. So it is an integrated system, a group of pieces or systems that drills wells. This rig drills wells, such as oil or water wells, in the side track subsurface. In the side track subsurface. The term rig, what does it mean, term rig? Therefore, generally refers to the complex equipment. You see, the components or equipment that is used to penetrate the surface of the Earth's crust. Earth's crust. There are 5 different types of drilling rig. We have, I will show you just now in the next slide, that drilling the well is created by drilling a hole. This hole will start with a bigger size, then smaller size, then the smallest size. We have conductor, we have surface casing, we have intermediate casing and production casing. Sometimes we have like liner. We have liner. If we don't want to make the casing till the surface to save money or the cost, then we can do it. So drilling the well is created by drilling a hole. This hole is decreasing when we go deeper into the earth using a drilling rig that rotates. We have 2 types of systems. We have a top drive system. This is the most modern system. And we have the Kelly system. Kelly system rotates a string, or we call it a drill string, with a bit attached. We attach the bit at the end of the drill string with the BHA, and we can make a progress. Re-entry well also can be carried out for the following operations. Either we can deepen or increase the depth of the well, maybe side tracking or recompletion. You see, these are the rigs that just now we talked about them. The right one, you see, this is onshore or land rig. These are the offshore. Offshore, we have barge, and it drills in shallow waters. Here, jackup rig, it operates at water depths up to 500 feet. In the Arab Gulf, all rigs are barge or jackup. Why? Because it doesn't have deep water. Deep water, maybe 100 meters plus minus, maybe 150, but this is the maximum depth. While the semi-submersible and the drill ship, these, we use them maybe in the North Sea, in the Black Sea, in the Gulf of Mexico. This has depth of water up to 12,000 feet. This one. Here up to semi-submersible rig up to 10,000 feet. This one. So we have different rigs. You see, this is land rig. This is a jackup. This is the barge. You see the barge. Maybe the 10 meters depth, the water. Maybe 15 meters, like this. Here we have semi-submersible rig rig or platform. And here, this is a Turkish drill ship, Turkish. We call it Yavuz. The drill were in the Mediterranean and in the Black Sea. They found gas in the Black Sea, and the government gave us gas for 1 year free of charge for 1 year. Why? Because they discovered gas, and for all the population of Turkey, 85 million, we took gas free of charge. We didn't pay anything. Now, wells can be exploration or production. I mentioned that to you. Maybe also between them, we have appraisal, only one well. We have vertical according to the shape. We have vertical. You see vertical, like this one. We have horizontal, this one, or deviated, this one. You see, and we have TVD and measure depth. What is the difference between TVD and measure depth? Now, here, if it is vertical, the TVD, true vertical depth, is same as measure depth. Exactly. While here, it is deviated, the measure depth, you see, it is longer than the true vertical depth. Longer. This is deviated. And here, we drill till point. We call this point kick-off point. Kick-off, K-O-P, kick-off point. Then we drill like dog leg to deviate the well in this area from here to here. Then here we can start drilling horizontally. In Abu Dhabi, where I worked for many years there, the standard is 5,000 feet or 1,500 meters. The horizontal section length, we call it horizontal section length. Now, what are the types of the wells at the production phase? We have 7 types of the wells. We have oil producer, gas producer, water injector, gas injector, WAG injector. What do we call it, WAG? Water alternative gas. Water alternative gas. We inject water for 6 months, then stop, then inject gas for 6 months. And so on. Why? Because it will improve the efficiency of the sweeping between the injector well and producer well, and avoid any breakthrough of the injected water. So this is a new technology. If you use it in Algeria, I don't know. We have water supply well. We can take maybe water, shallow water, maybe at 1,500 meters or 1,000 meters. We can take it and inject it into the water injector wells. Why? To boost the reservoir pressure. To boost the reservoir pressure, we call it reservoir pressure maintenance. Reservoir pressure maintenance. We have also water disposal well. If we don't want this water, we can dispose of this water like mud from the rig. We don't need it. Instead of throwing it in the desert, you can inject it here. And from time to time, we have to go to these wells. In Abu Dhabi, we are having 8 wells, water disposal wells. From time to time, we do acid stimulation to dissolve the fluids that can plug the formation and increase the injection rate into these water disposal wells. Now we have the completion. The second step is the completion. After completing the drilling of the well, we have to complete it, because if you produce the well and expose without completion and expose the casing to the oil, water, and gas from the reservoir, it will make problem or failure in the casing. You will lose the well. And if you lose the casing, what will happen? You will lose the well completely. So we have to isolate the casing from, you see, we have packer here. We have packer, you see this one. So here we have the completion. We like conduit. This is the conduit to the surface. Either oil produce, we can produce, or we can inject, both ways, through the conduit, or we call it tubing. The tubing may have different sizes. If you write them down, please, we have size 2 and 3/8. We have 2 and 7/8. We have 3.5. We have 4-inch and 4.5-inch. This is the tubing size. It is the main part of the completion, and we run with the completion tubing accessories like gas lift valve, mandrel, like SSD, sliding side door, like subsurface safety valve, like nipples, etc., all of them. And at the end, we have to run the wireline entry guide also to safely recover the well intervention to the stream. Here we have vertical, you see, vertical completion, and we have horizontal. So both types, because if we drill a horizontal well, then we have to run the completion to this one, and here also to the vertical. This is the bearing, the reservoir or hydrocarbon bearing formation, this one. So completion includes running production tubing. What I explained now, it is here. And its accessories, you see accessories, SSD, subsurface safety valve, tubing hanger, etc., in the hole to the required depth, as well as perforation and stimulation as required. And we do also perforation, stimulation, frag, etc., etc. Completion design criteria, it should give us the profitability, provides a production optimization. So if we expect to produce 5,000 barrel, we don't run 2 and 3/8, we run, for example, 4-inch tubing. If we have production maybe 500 barrel per day, we don't run 4.5. We run 2 and 3/8 or 2 and 6. So it should be profitable and minimizes operating cost. We call it OPEX, this one, operating cost over its life. A flexibility, it should be flexible for handling the current and future problems. Simplicity, it should be simple as possible to allow the most efficient installations and maintenance activities. Here the completion objectives, what are they? You see, this is an example of the completion. We call it a single selective completion. Single selective completion. Look at this. We have how many reservoirs? 1, 2, 3. We call it bottom zone, middle zone, top zone. And we isolate this from this from this. We're using the packer. You see, packer number 1, 2, 3. Now, if we want to produce from this one, we close the SSD, we call it sliding side door, and set the plug here. We can open this SSD, and if we want to produce from here, we close SSD, set the plug here, open SSD. If we want to produce only from here, we close SSD, and produce from them. So the completion, this one, will protect the casing, as I told you. Because why? Because the fluid has too many things. It has pressure, temperature, H2S, CO2, salts, water, asphaltene, sand, wax, etc., etc. So we have to protect the casing, because if you protect your casing, it will serve you for maybe 100 years instead of you lose your well. So provides optimum flow condition. Optimum flow conditions. Downhole emergency isolation. So for the subsurface safety valve, if any fire, any earthquake, any problem happens on the surface, this will close and secure the well. It will secure the well. Number 3, downhole emergency isolation. Number 4, permit downhole chemical injection. So we can run the control line. You see this control line, for example, and pump corrosion inhibitor. Why? To reduce the corrosion in the completion, in the flow line, in the station, etc. Permit downhole measurements also we can, especially in the smart completion, we can set pressure and temperature gauge. We can set ICV or ICD, inflow control valve or inflow control device. We can open and close any zone or any reservoir and close the other one. We can control it. So permit downhole measurements, isolate producing zones by opening and closing this and other. Now allow selective production. This selective production, as I told you, we can produce either from here or from here or from here. Sometimes, if the pressure between this are the same, we can open them together. We can open all the zones together and produce from the completion. We have a classification of completion. We have open hole and cased hole. This is open hole. We run the casing. We call this one casing shoe. Here we drill here, maybe 100 feet, for example. This one will stay without casing, this one. But it should be consolidated reservoir. What do we mean consolidated reservoir? It should not be sandstone, because sandstone is moving from the formation to the bottom of the hole and it will plug. But if we have, for example, limestone, if we have dolomite, if we have like this, then it will not move. So we can, and it has advantages and disadvantages. The advantage is the cost will be less, there will be less contamination. But for the disadvantages, if we run the casing with the cement, it will make pollution. It will make pollution. It will make restriction between the formation and the bottom of the hole. We have a cased hole, perforation. You see, we have cased hole, perforated hole. This also cased hole and perforated. You see, we run casing. Behind it, we pump cement and we perforate it. You see, perforation. And we have a dual packer. We call this one dual packer. And here, single packer. Single packer. If we want to produce from this one, we close this SSD. We call it sliding side door, SSD, and make this open. And we can this one. Or if we have single, we have short string. We have short string, this one, we can produce from here, you see? Or if you want to open the SSD, you can produce together from this and this if you want to open this SSD. Otherwise, you can produce it through the short string. This is long string and this is the short string. We have multiple zone completion, multiple, more than zone, one zone, two zone. We have single completion, this one. We have dual completion, short and long. We have short and long. So single completion, we have single selective completion. Single selective is this one. Where is it? This one, single selective. You see, single selective. We have dual completion. This is dual completion. This is dual completion. You see this one. We have dual selective completion. This is dual selective. You see, selective completion. These are the, we run the packer to isolate the zone above the top perforation and the tubing. This is single tubing and we can produce from here. Here we can produce from the top completion, a top reservoir, and here from the bottom reservoir. So long string and short string. Here we have also, this is single vertical well. This one, we have packer. We call this one tailpipe. You see, this one, we call it tailpipe, this one. This is top completion. From the tubing hanger to the packer, we call it top completion. This is bottom completion, below the packer. We have single selective, as I showed you just now, single selective vertical. We have dual. This is short string, this is long string. Here we inject water, for example, here, the blue one. Here we inject gas, you see, gas. Here also we have this one. What do we call this one? Single slim hole. Single slim hole. Maybe a small size tubing. We call it single slim hole. Here we have vertical, and we have here horizontal well. We have vertical and horizontal, and all the items or the components, you see them here. Now, another subject, if the well is not able to produce naturally, what shall we do, my friends? We have to use the artificial lift. We have 5 artificial lift methods. We have gas lift, we have ESP, electrical submersible pump, we have beam pump or sacral, we have PCP, progressive cavity pump, and we have hydraulic or jet pump. Here, the gas lift, you see, we inject gas from the annulus and produce via the tubing. We have different side pocket mandrels, 1, 2, 3, for example, maybe plus, maybe less. And we have software to choose the depth and the number of the side pocket mandrel. But here you need a source of gas to inject into the annulus, a source of gas. So it will reduce the hydrostatic pressure in the well and produce to the surface. Here we have ESP. You see, this is the ESP. Also, we can use it, run the cable, the blue one, to the motor. The motor will operate the pump, and we have stages here. We have a diffuser and impeller. Diffuser and impeller, and we have every diffuser and impeller, we call it stage. So we may have 50 stages, we may have 100 stages. When the stages increase, then the productivity will increase of the ESP. We have also beam pump, this one, or sacral. You see the pump down, we have sacral, and up we have polish rod. Here we have stuffing box and to the floor. This will produce maybe 500, 300, 200, up to 1,000 barrel per day. While the ESP, it may produce till 30,000 barrel per day, 30,000, maybe 10,000, maybe 20, maybe, but it has high capacity. This one, low capacity. Here, PCP, we use it for the high viscous oil reservoirs, high viscous oil reservoirs. I worked in a company, 3 fields are having high viscous oil. So we produce maybe 50 barrel from each well, not that much. But we use the motor, and we have rotor and stator. Rotor, and you see these ones. Rotor is the moving one inside, and the stator is the fixed one. Like here, nitrile. We call it nitrile, right, like rubber. So when this moves like this one, it will make like centrifuge. It will produce the oil to the surface. And we have this motor, a prime mover. Also, the jet pump, when we install jet pump down, it is not here, install jet pump maybe here somewhere in the SSD. Then we pump water. It will go to the annulus. The annulus will mix the oil from the well with the water from the surface. It will make like suction, It will make vibration or suction, and will reduce the pressure to the reservoir and will produce to the surface from the annulus. On the surface, we separate the water that we pump from the oil that we produce from the reservoir. And in this case, we can take the oil and re-inject the water again. We call it a hydraulic pump or jet pump. Here is the completion. This is top completion. This is bottom completion. We have packer. We have tubing hanger. Tubing hanger has four functions. What are these functions? Let me read what somebody, Mr. Osama, is asking. What are the operations used to open and close the packer? The packer, we have either permanent packer or retrievable packer. The permanent packer, we run it either with a drill string or with the electric line. We set it, and this needs milling to retrieve it. When we have workover, we have to retrieve it using only by milling. This question comes in the exam of the well control. How can you retrieve the permanent packer? We can run it either with electric line, set it, we send electrical signal and set it, or by the drill string, we can drop a ball and make a hydraulic setting. For the retrievable packer, we have two ways to set the packer. We have two ways. The first way, we can run it with the completion or the completion that we set it in the well. Then we set the plug here, for example, this one. We set the plug here, and then we increase the pressure above the plug till the packer sets. This is number one. We call it hydraulically set. The other one is by rotating the completion. We were rotating it maybe 6 turns, 7 turns, 8 turns. It depends from packer to packer. Then we reduce the weight slowly, maybe within 1 meter or 2 meters. Then it will sit, and the packer has slips and packing. I will show you the packer just now. It has slips that can catch the casing from the inside and has the packing. This packing can isolate top from bottom. Now, the retrievable packer, I told you permanent packer, we need milling. We need milling. While here, when you pull the completion, the packer will release and you can take it with the completion without any milling, without anything. And is it clear, Mr. Osama? My friend, is it clear? Yes, it is clear. Okay. Any question, you can write it down here, please, and I'll answer straight away. We have the accessories that we can run with the completion. These we can this, for example, the packer. This one we have perforated pop joint. We have landing nipples. We have a sliding side door like this one. Side pocket mandrel also in the gas lift. We have SSD sliding side door. All of them and subsurface safety valve for safety. This should be from surface up to 2,000 feet. Up to 2,000 feet, not more than that. Okay, thank you, Mr. Osama. Let us continue. Here we have the completion accessories. As I mentioned, these we have to know what is the function of each one of them. We take them from bottom to top. For example, wireline entry guide. What is the function of the wireline entry guide? When we run the coil tubing or the wireline tool string out of the completion, we have to return it back to the completion. Otherwise, it will get stuck and we need workover in this case. To avoid this problem, we install wireline entry guide. It has a shape that will facilitate the re-entry of the wireline tool string or the coil tubing tool string. So this one. A landing nipple, we can set a plug, we can set a gauge, a bomb hanger, we can set different tools in the profile, landing nipple. Perforated pop joint here, we use it when we do the surveys, pressure and temperature survey. We have selective profile nipple. We have two types of landing nipple, selective and non-selective. Non-selective, we have only one. If you write it down, because you see, we call it no-go landing nipple. Bottom no-go, this one. For the rest, we have top no-go or selective landing nipple. So selective landing nipple, you can put maybe 5, 6, 10. But while for non-selective or no bottom no-go, we can put only one in the deepest point in the well, deepest point in the completion, this one. We have a hydraulic set packer. As I told you, we set the plug here in the nipple, then we increase the pressure, the packer will set. Maybe 1,500, 2,000, it depends on the type of the packer and the procedures for it. Sliding side door, SSD, we can set it here. Where is it here? Sliding side door, this is SPM. SPM, we have sliding side door here somewhere. I don't see it here, but sliding side door, it doesn't appear. But if we come back, you see, this is the sliding side door, this one, you see. Why do we install it here? To circulate the well from the annulus to the SSD to the surface, to kill the well by reverse circulating. We have a sliding side door. We have side pocket mandrel for the gas lift. For the gas lift, we can set gas lift valve in the side pocket mandrel. We have subsurface safety valve for the safety. Where is the subsurface safety valve? Tubing where is it? This one, subsurface safety valve. You see this one. What else? We have tubing hanger. Tubing hanger has four functions. If you want to write them down, it will be better for you, because it will add more value for you. And also this comes in the exam. It can hold the weight of the completion. You see, the weight of the completion. This is number one. This is the tubing hanger. You see this one. It can hold the weight of the completion. Number two, it can isolate the tubing from the annulus. It can isolate the tubing from the annulus. Number three, we can set in the profile here, there is profile, either back pressure valve or two-way check valve. Back pressure valve or two-way check valve. Number four, we can run control line. You see, this is control line, you see, for the subsurface safety valve through it. So four functions. Blast joint, we use it when we have like this one. I will show you like this one. You see blast joint. You see blast joint. Here, if we have this like this zone, and the flow is colliding, or flow of the fluid is colliding with the tubing from the outside, it will erode it. By time, it will erode it. In this case, what shall we do? We have to put a blast joint that has the same ID, but bigger OD. So we can use it. We can use the nickel, chromium, extra alloy, special alloy, to reduce the erosion of the fluid. So this one, we call it a blast joint. You see, opposite to the formation. It may be 20 feet, 30 feet, 10 feet. It depends on the length of the perforation. A blast joint. We have flow coupling also to reduce the erosion, maybe for the SSD, for the subsurface safety valve, or for the nipple, before and after. You see, flow coupling. Where is it? I will show you next also. A flow coupling. Where is it? This one. You see, flow coupling. We have flow coupling. So before and after the landing nipple, for example, before and after the SPM, before and after the subsurface safety valve. We have the wellhead also at the surface. We talked about all of these. These are the tubing hangers. You see, tubing hangers. We have also the back pressure valve and two-way check valve. The right one is two-way check valve. This is to secure the well. These are used to secure the well, and we can set them where? In the tubing hanger profile. tubing hanger profile. This one is the tubing hanger, the green one. When we set it, we have to close the what do we call the fingers or tie down bolts. You see, tie down bolts, because by time, what will happen? There will be very high pressure that may push the completion up. While if we close the tie down bolts, the red ones, it will catch it mechanically. It will catch it mechanically and it will prevent it from jumping up. Here is the subsurface safety valve, and we have different videos. Now it is not easy for me to show you videos. We may need 10 hours or complete course. Just I want to give you an idea. So this subsurface safety valve is a device installed in the upper well bore to provide emergency closure. If you remember, in 1991 in Kuwait, there were many wells burning as a result of the war. And there should be subsurface safety valves. But after that, the whole world has earned a lesson plan, lesson learned that every well that has the potential to flow naturally should be equipped with the subsurface safety valve. And we have two types of subsurface safety valve. We have surface control and subsurface control. Subsurface control, we don't use it for the time being. It is old model, but we have to know an idea about it. We open it by increasing the pressure in the tubing and close it by reducing the pressure in the tubing. For the surface control, we run the subsurface safety valve like this one, and control line. The control line is stainless steel. The grade is 316. We can run it to depth less than 2,000 feet. Maybe 1,000 feet, maybe plus minus, but we have two types, tubing retrievable and wireline retrievable. You see, this is the subsurface safety valve. We can run it. Suppose that the tubing retrievable has failed, we can lock it open and install the wireline retrievable. You see, wireline retrievable inside. This is as a temporary solution. And we have the locking mechanism. We have a flapper and ball and seat. We have ball and seat and the flapper. Or you see, this is the flapper. It is open. This one. You see, this is the flapper. This flapper is closed. This flapper is closed. So we may have this or this. We can secure the well. The production tubing, we have different sizes, as I told you, and it will be the conduit from the formation to the surface or from surface to the formation in case of the water injector. And this tubing may be burst, may be collapsed. You see here it is burst. Why? Because we applied the pressure inside more the pressure outside, more than the burst pressure. Maybe the burst pressure is 3,000 psi, so we apply 3,000, it will like explode from bottom, from inside to the outside, or collapse from outside to the inside. How can we connect the tubing joints between each other? Using the tool joint. You see the tool joint, this one, we call it tool joint. And it has a length, the standard length that we use is 9.6 meters or 30 feet, 30 or 31 feet. You can use this one. For the casing, we use the standard length is 40 feet, 40 feet for the casing. And now the packer, we talked about it, tubing retrievable, and you see a retrievable packer and a permanent packer. The permanent packer, as I told you, it is used in high pressure, high temperature wells, and it needs milling. You see, it can be retrieved only by milling. For the retrievable packer, when we pull the packer, it will release. When we pull the completion, the packer will release. That's it, very easy. So this is very easy. This is the packer, my friends, look at it. We have slips, up and down, we have packing. This is neutral, or we call it. We have single and we have dual. This is single and we have dual. This is short string and this is long string. You see, we can do it. This is we call this one what is the heart of our well completions, the packer. It is the heart. For example, if we want to produce from here, we can set packer here, and then we can produce it to the surface. The landing nipple, as I told you, we can set we can set plug, we can set the boom hanger, we have different types of the, it is a place to set the plug, wireline plug. Or we can set, for example, a gauge, boom hanger. Or we can, so we have three types. We have no-go nipples. We have this one, only we run one. We call it bottom no-go. We have selective landing nipple. We have maybe 2, 3, 4, whatever. The no-go will be from the top. While this one, the no-go will be from the bottom. From the bottom. We call it like R nipple or XN nipple, depending on whether Otis or Baker. For Otis, we have F nipple and R nipple. For Otis, for Baker, we have F nipple and R nipple. For Otis, we have X and XN. We have ported or safety valve landing nipple. As I told you, when the safety valve tubing retrievable has failed and we don't have workover, we can set the wireline retrievable inside the tubing retrievable, and we can, this is as a temporary solution. This is the bottom no-go or no-go landing nipple. We set it in the deepest point of the well. Or for the Baker, we call it R nipple, or for the Otis, we call it XN nipple. You see, XN nipple. You see this one. We have only one. Look at it, only one. You see, only one. It is in the deepest point of the well. We have selective nipple. Maybe we may have 2, 3, 4, 6 like this. The top no-go, it has no-go, but from the top. Safety valve landing nipple, just now I tell you, if the tubing retrievable has failed and we don't have workover, we can set the lock open the safety valve and install the wireline retrievable inside the safety valve landing nipple. Circulating devices like SSD, I explained about SSD, and just now I will explain. Also, we have side pocket mandrel. What is SSD? This is the SSD, you see. It has two positions, open and closed. This is closed, look at it. We have a sleeve. This sleeve can be moved up and down, up and down. It has holes here and has holes here. When the holes are not opposite to each other, then it will be closed, you see. When it has the holes opposite each other, it is open. So we can pump from the annulus to the tubing to the surface, and we can circulate the well. Here you cannot do it. This is the SSD complete one also, but here it is more clear. You see, this is the SSD. If you go to the workshop, if you have workshop, to one of the companies and take this one, and ask them where is the SSD, where is the side pocket mandrel, where they will show you the subsurface safety valve. The side pocket mandrel is this one. We can, like a kangaroo, you know the kangaroo, where does the kangaroo put his child or her child? In a pocket. We call it, like here, side pocket mandrel. So here we set the gas lift valve, and we can produce from the annulus gas. We pump gas to the tubing to the surface. How can we set the gas lift valve? Using the kick-over tool. We call this one kick-over tool. Here we talked about flow coupling and the blast joint to reduce the erosion. You see these. A flow coupling also. Polished bore receptacle. We install this one where between the tubing and the packer. Between the tubing and the packer. We call it polished bore receptacle. Or we call it another design, we call it seal bore extension. Or the other design, we call it a tubing seal bore receptacle. So, what is the reason to install this PBR? Because the tubing, as it is producing, it will expand. The temperature will increase and the tubing will expand. Now, if it is one part with the packer, In this case, it will unset the packet or cause damage to it. While if we put it, for example, here in this area, we call it top stroke. Then if it expands, then of expansion will move it from here to here or from here to here in the worst case scenario. So it will not be affected. For example, if it moves from here to here, then it will be okay. Now, if we inject water, it will shrink the tubing. The length of the tubing will be less. So if we put it here in the beginning, if it will be less, it will move from here to here, or in the worst case scenario to here. So it will be healthy. Each one of them needs more explanation, but for the time being, take an idea, and in the future, you can repeat it. You can watch video like this. You can make more information and more knowledge about it. You see, either we have male, the other one is female, PBR, or the expansion joint, we have male from top and female from the this one. Wireline entry guide, as I told you, we can run the wireline tool string or coil tubing tool string or whatever out of the completion. Then we can return it back safely to the completion. And we have two types. We have bell guide, this one. We run it in the vertical. We run it in the horizontal well and highly deviated well. This one. And this one we can, we call it mule shoe. We run it also in the vertical way. For the wellhead, this one, the wellhead, we call, this is the Christmas tree, but the whole one, we call it wellhead. From the bottom, from the cellar to the tree cap, here, the pressure gauge. We call it, this one, this is for the surface casing. This is inductor, conductor. This is surface casing, intermediate casing, surface casing. Then we have the tubing hanger here, and we have the Christmas tree. So all of them, we call it wellhead, all of it. We have two types of the Christmas tree. It is controlling the production or injection. We have conventional Christmas tree, and we have monoblock. We have monoblock. We call this one monoblock. You see, Christmas tree. We use this one for high pressure, maybe gas wells. This one for conventional, maybe oil wells and intermediate pressure, not high pressure. And we have lower master valve, upper master valve, swap valve, killwing valve, flowing valve, and choke valve. The choke may be 2-inch or 3-inch. For the monoblock, we can use it for the gas wells. It will be one part, this one part. For this one, we have flange. You see, flange between valves. We we call this one a cross. You see, cross, this one. Here we have the tubing hanger here. We have the conductor, surface casing, intermediate casing, production casing. You see, and this is production tubing. You see the Christmas tree, this one, or the wellhead, for example. The Christmas tree is from here to here. We call this one. But all of it, we call it wellhead. You see? This one. This is gas well. You imagine the Christmas tree, how much it is big. This one. Here also, we have conventional Christmas tree, the green one. We have monoblock for the gas well, and we have compact or subsea. What is subsea? You see, monoblock, this one, we have monoblock. This, we use it for the gas wells, Here is the subsea. You see, subsea. We have vertical and we have horizontal. Here also, the subsea. I don't think you have a big idea about the subsea, but take an idea now. How can we control it? We can run like a robot. We call it ROV, remote operated vehicle. This remote operated vehicle, we can replace something, repair something, because at depth maybe 1,000 meters, 2,000 meters in the Gulf of Mexico or in the North Sea, for example, you cannot send somebody and ask him to dive and go there and do this and this. No, you can send ROV like a robot, and you can control it as if you are playing games. You are playing games. So it has a simple principle, and you can replace whatever you want and control the way. This is dual Christmas tree. You see we have short string and long string. We write down on the short string SS. For the long string, we write LS, long string. Here we have the second rod or beam bump wellhead, you see. We measure the pressure. Here we have stuffing box, polish rod. We have the tubing hanger here. We have also the production line is this one. Here we have the gas, venting gas from the annulus. At a main pressure, at a certain pressure, it can open and relieve the gas from the annulus. Here also we have ESP. When you see this one, this means it is ESP. Why? Because we run the cable, electric cable from the surface to the motor. The origin of the oil and reservoirs, as you studied in the university, we have source rock. This source rock has been buried, and under pressure and temperature, it moved from shape to shape. The organic materials became hydrocarbon. So we have the source rock, we have the reservoir rock, where the oil and gas have accumulated. We call it reservoir. Above the reservoir, what do we have? We have cap rock. Normally, it is shale or anhydrite or salt. For the reservoir, normally it is either sandstone or carbonate. Sandstone or carbonate. We call it the carbonate either dolomite or limestone or calcium. You see, this is the source rock. It will move up to the reservoir. This is the reservoir. Here we have the cap rock. We have the cap rock. We have different types of the trap. We have anticline trap. We have fault trap, we have stratigraphic trap, and we have reef or salt trap. Different. These are the main types of trap. Have you studied the traps in the university or not? You have any idea about this? The origin of the oil or not? You didn't take it? Just tell me yes or no, please.
For some students here, we have an idea, but for some, no.
Okay, now you can add some of the information to your knowledge, and you can search maybe in the Google, maybe in some books. You can ask your doctor, what is this? What is this? At least the doctor will not give you the full picture, right? He will give you the main subject, and you have to do search. So this is part of the search. Now for this video, if you do maybe repeat it 1 time, 2 times, I will put it in my YouTube channel. If you watch it for 2 times, it is more than enough. 3 times, it is perfect. So you can make notes also. For me, always I take notes. This. So I review them 1 time, 2 times. It will be no issue. So here also we have the source rock, you see. We have migration to the reservoir. And here we have the cap rock, you see. We have cap rock. Normally, the gas accumulates in the top, then the oil below it, then the water. Here also gas, depending on the density of the fluid. Now for your information, my friends, the liquid, we call it oil and water, we call them liquid, oil and water. And they cannot be compressed that much, maybe very limited compression. While the gas, it is compressed, and we can apply the Boyle's law. Boyle's law, which is P1 V1 equals P2 V2. P1 V1 equals P2 V2 at the same temperature. As the pressure increases, the volume decreases. As the pressure decreases, the volume increases, and so on. Let me see how does the subsurface safety valve function in a Christmas tree. It is not in the Christmas tree, my friend. It is deep in the hole. I told you, maybe at 500 feet, 1,000 feet. We connect it to hand pump and apply pressure. Apply pressure to the control line, and this will make it open or close. If we increase the pressure in the control line, it will open. If we bleed off the pressure in the control line, it will close. That's it.
Hello?
Yes?
Am I hearable? Is my
Yes?
voice clear?
Yes, please.
I was the one who asked the question. I
Yes.
meant how the SCSSV does it like we put it in the well while constructing, or we put it from the lateral valve in the Christmas tree, then we put it in the well, we use it, then we get it out.
No. When you run the completion, it will be part
Yes.
of the completion.
Okay.
At depth,
Okay.
maybe 500 meters, 300 meters. It depends on the company's policy. Okay? Okay.
Okay. Thank you,
And
sir.
thank you. And it will be connected to the control line, quarter inch. At the surface, we connect hand pump. When hand pump
Yes.
increases the pressure in this control valve, it will open. When we bleed
Okay.
off the pressure, it will close. Okay, clear?
Okay. Thank you, sir.
Thank you. Now we have gas, we can compress it, but for the oil and water, we cannot compress it. All of them, what do we call them? We call them fluids, oil, gas, water. But for the oil and water, we call it liquids. So we have to differentiate between this and that. Now, let us also go to, this is caprock. This is the reservoir. This is source rock. From source rock to the reservoir, and we have caprock. This caprock is to prevent the hydrocarbons from going to the surface. Why do we call it hydrocarbons? Because we have atoms of carbon and atoms of hydrogen. Atoms of carbon and atoms of hydrogen. So we call it hydrocarbons. So these ones, maybe methane, ethane, propan, butane, hexane, pentane, and so on. So different names. So you have to know them. Gas, oil, water, depending on the density of the fluid. Here we have caprock. It is impermeable. This is permeable. We have traps also. As we mentioned, we have anticline, we have salt dome. You see, this is salt dome. We can drill from this side. We have anticline. We have fault. We have, you see, fault control and so on. Sometimes we drill relief valve. For this one, if we have fire here and the well is producing, so we drill a relief well maybe at 200 meters away from this one, and we can drill deviated well, this one, you see. Reservoir characteristics, we have porosity and permeability. And all of that data, the porosity is the percentage of the voids in the reservoir. Maybe the volume of the void is 40, for example, 40 millimeter, for example, and the total is 100, maybe 40 divided by 100, it will be 40%. So we take it as a percentage. It doesn't have unit, percentage. So the percentage of the pore spaces in the reservoir. This we call it permeability. This is porosity. While the permeability is the ability of the reservoir to pass fluid through it under delta P. The ability of the reservoir to pass a fluid through it under delta P, differential pressure. And we call it, we use the millidarcy. We use the millidarcy. Here we have unit. We use the Darcy or millidarcy. Hydrocarbons, as I mentioned now, we have about 1,000 compounds, 1,000 items of these that can be obtained from the oil, crude oil, like plastic, like fiber, like rubbers, explosives, solvents, etc., etc. Oil, gas, water, asphalt, wax, all of them. So the combination of carbon and hydrogen, we call it hydrocarbon. And you see, we have methane, ethane, propane, butane. You see, this is butane or paraffin. C4, H10. This is C4H10, you see, and so on. This is naphtha thin. This is naphthalene. Naphthalene, we call this one. And different benzene. This is benzene, you see. C6H6. C6H6. We call it benzene. We have bubble point pressure. It is the pressure at which the first bubble of gas will release from the fluid. This one, always we have to keep the reservoir above the bubble point pressure to avoid releasing the gas from the reservoir. It is very important. And this one, I think you have studied it in the university. Where is the vapor? Where is the liquid? Where is the mix between them? It depends on the temperature and the pressure. You see, this is temperature and this is pressure. We go through it this one. This one, we have a critical point. Above it, we have gas. Below it, we have liquid. So the relationship between pressure and temperature. The reservoir drive mechanisms, we have different. The most famous one is water drive. We have gas cap drive. We have solution gas drive. Also the depletion drive. We have gravity drainage. We have combination of more than one. You see all of them. These, you see drainage. This is the gravity drainage mechanism. The gas will go up and the oil will go down. Here also we have combination more than drive mechanism. The productivity index, it is the equation Q divided by delta P. Delta P is the reservoir pressure minus the bottom hole flowing pressure. This one. Where the unit J or productivity index PI or J, the unit is stock tank barrel per day per PSI. This is the unit. Look at it. Stock tank barrel per day per PSI. This one. It is very important for the reservoir study. This is another example for PI also. Initial oil in place, also all of these, I put them just to refresh your knowledge because you should take it in the university. How much is original oil in the reservoir? We call it, the unit is stock tank barrel. We need the porosity, we need the thickness, H, we need the area. We have constant here also. We have water saturation. We have also oil formation, volume factor, oil formation, volume factor. All of these, we need them. Also, Boyle's law, as I told you, P1 V1 equals P2 V2. We call it Boyle's Marriott law. You see, Boyle's Marriott law. We suppose that the temperature is constant, then PV equals constant. We can use this one. Look at it. P1 V1 equals P2 V2. You see, when the pressure increases, the volume decreases. You see, when the pressure decreases, the volume increases, and so on. You see this one. At the same temperature, you see, when the pressure increases up, the volume decreases. and the vice versa. Production stage, now when we produce the well, we have 3 stages: upstream, from the reservoir to the surface. Then when we take the oil and gas for storage, transport it, do processing, storage. Then this is midstream. Then downstream to the refinery, and we can do marketing for it. So these are the main 3 stages. You see, this is from wellhead. It will go from the wellhead to the station. Here is the station, this one. Now for the gas lift, this is the gas lift. We inject gas from the annulus to the tubing to the surface, and we can reduce the hydrostatic pressure. We call this, the production can be classified into 3 main stages. What are they? The primary, which is natural flow. Secondary, we may need artificial lift, gas lift, pumping. The pumping, we have 4. We took them: ESP, beam pump, BCP, jet pump. We have tertiary, like using, we call it EOR, enhanced oil recovery. We have polymer, we have chemical, we have heat, we have carbon dioxide, explosions, etc. Maybe burning the formation. We call it in situ combustion. In situ combustion, we can fire the part of the reservoir. In this case, it will increase the temperature, and we can reduce the viscosity of the oil, and it can move easily to the oil producer. Here we have ESP. These are the parts of the ESP. Where is it? We have a plunger. This is the tubing, casing, gas lift valve. This is gas lift. We can pump gas from here to the gas lift mandrel to the surface. Here, what is this one? This is the controller. We have lubricant catcher. This is a plunger. This plunger is moving from bottom to top, and then it will drop down. In every time it goes up, it will push all the volume in the tubing to the surface and produce it. So this one, we close the well first and allow this plunger to go down. Then we open it very fast. It will push the plunger up, and it will push in front of it the oil and gas to the flow line. We call it plunger or hydraulic pump. Here we have the ESP. As we said, we have motor, we have equalizer. The cable is this one, the green one. We have intake, like gas separator. We have the pump and the tube. What else, my friends? These are the parts of the ESP. And we have this one. Beam pump, we have pump, we have second rod, and to the surface unit. We have horse head, polish rod, beam, and we have counterbalance here. We have crank, we have a prime mover or motor to the flow line, this one. We have PCP. It is used for the high viscous oil. High viscous oil, we have motor, we have second rod, we have rotor, and stator. You see these ones. We have jet pump also. We have diffuser, a nozzle, diffuser, a throat, nozzle. We make like reduce the pressure to make suction of the fluid from the reservoir to the annulus. Gas lift system, this is by pumping a gas into the annulus and take it through the tubing. And we have different types of the gas lift valves: gas lift valve, dummy valve, gas injection valve, dump kill valve. We have circulation valve also. We run and pull the gas lift valve using the kickover tool. This one. These are the types of the gas lift valves. For the well intervention, we have 3 main types of the well intervention. We have wireline, we have coiled tubing, and we have snubbing. For the wire line, we have three types. We have slick line, like this one, either stainless steel or carbon steel. If we have H2S, we use stainless steel. If we don't have H2S, we use carbon steel. It is cheaper. For the size, we use 0.108 or 0.125. There is less and there is more, but these are. For the slick line, we can do different operations like open, close SSD, set, pull, gaze, set, pull gas lift valve, set, pull subsurface safety valve, etc., etc. You see, this is the braided line. A braided line is used for fishing of the slick line and also for swabbing. Electric line, we use it for the setting the packer. This is number one. Number two, for logging. Number three, for perforation. Number four, for logging. Four. I will repeat them. Set packer, logging, perforation, and what else? Set packer, logging, perforation, and what else? Remind me. I just mentioned it. Set packer, logging, perforation, and water shutoff. Yeah, this one. Okay, I forgot it. So we have to. This one has two main sizes, 316 and 7/32. This braided line doesn't have a brass inside it in the middle. So it doesn't conduct the electrical signal from surface to bottom, while this one has brass conductors, single conductor or multi-conductor. This one. You see, this is 5 days. This one, every type of the operation that I give you, it needs 5 days explanation. So maybe in the future we can go into details more and more. This is the wire line to the string, rope socket from top to bottom, rope socket, stem bar, mechanical jar, a knuckle joint for deviated well, and we can run the tool, maybe running tool, pulling tool, etc. These are the tools that we can run in the well. Fishing also, if we have fish, we have to know how do we control it to avoid more complication of the operation. Here, braided line, as I mentioned, fishing and swabbing. The 316 and 7/32. The E line, as I told you, logging, perforation, water shutoff, and set packer. And these are the explanations about it. Perforation, we can perforate. You may visit some perforation, some logging, some extra, and take more information. We perforate either overbalanced or underbalanced. We have coil tubing also. It is very, very good invention. We can use it in the well intervention. We use normally 1.5 inch, 1 3/4, and 2 inch. We can use it especially for stimulation, for operation in the horizontal section, highly deviated wells. And we can pump through it. We can do logging. We can do everything. Here are the parts of the coil tubing package. We have BOP. We have injector head. We have power pack, reel unit, control cabin. You see, we can do these operations and maybe double of them. Maybe we can count about 20 or 30 operations for the coil tubing. But the main operations: logging, cementing, nitrogen kickoff, coil tubing conveyed perforation, open and close SSD in horizontal completion, stimulation and fracturing, scale and sand clean out, milling and fishing. Here we have nitrogen unit. Here we have pumping unit. Set cement plug using the coil tubing. These are the procedures. I put them for you just to follow it if you like. This is balanced cement plug. And we have calculation we can utilize. This is the bridge plug. Also, we can isolate the water producing zone. We can set cement above it. Nitrogen kickoff. If the well has died, we can use the nitrogen to lift it safely. Then we can pull the coil tubing to the surface. Coil tubing convey perforation. If the well has high deviation, we can run the perforation guns on the coil tubing and do perforation. You see, these are the guns. Also open and close SSD in the horizontal completion. We can do it. This one, we have smart completion, horizontal completion. Well stimulation, we have two types or four types of stimulation. We have acid wash, acid matrix acid stimulation. We have fracturing and acid fracture. All of them, each one needs more explanation. And now I give you this one just to have a look at it. We use 15% HCl or HF. HF is used for the sandstone reservoir, and for the carbonate reservoirs, we use hydrochloric acid, 15% or 20 or 28%. What is the raw acid percentage? It is 32%. Also, we can use organic acids, which are acetic acid, CH3COH, and formic acid, HCOH. And we use mix of them, 14:1 or 13:2 or 12:3. We can use them together. And we have chemicals. We can add friction reducer, surfactant, iron sequestering agent, diverting agent, non-emulsifier, anti-clay, all of them, corrosion inhibitor. Here, this slide is explaining about how do we do the acid stimulation. You see, acid stimulation. Hydraulic fracturing, it is the pressure at which the formation will be fractured or breakdown. Then we pump proppant, you see, proppant to keep the rock open, the formation open. Hydraulic fracturing stays, these are the stays. We have a proppant like sand, this one, artificial sand. You see? And this is the frag operation. And it can cost $1 million, $2 million like this one. Scale clean out, if we have a scale or a sand, we can do clean out using the coil tubing, and we can run rota wash on the coil tubing. We can use gel, high viscous gel, and do circulation. You see this one. Milling also, if we have a stuck tool or a plug or anything, we can do milling for it. We have different types of milling tools. Fishing also, the fishing, you see. Pumping, we can pump any fluid, cement, nitrogen, diesel, anything. We can use that because we, with coil tubing also, pump and coil tubing, because it can go into the horizontal section and we can pump. For example, pumping slurry plugs, cement plug, pump gravel pack, for example, pump nitrogen, pump acid, stimulate acid, and so on, scale removal, all of them, we need pump. Wellhead maintenance also, we have to keep the wellhead in a good condition to avoid any problem. Workover, we can move the workover and do maybe pull the completion, run another completion, repair the casing if it is leaking. We can make pull, for example, a single completion and run dual completion or vice versa, etc. You see, this is the workover. Well kill methods, we have four main methods. We have reverse circulation from annulus to tubing through the SSD or side pocket mandrel. We have forward circulation from tubing to annulus. Bullheading, we can bullhead to the formation, and we have lubricate and bleed. And we have the charts like this. We have logging. When we drill the well, we have to run open hole log. It will be the reference log, this one. And we have different too many types. I have lecture in the YouTube channel about open hole logs and cased hole logs. It is especially for this slide. So each one needs 5 days for explanation. So go through it, please, and you can utilize it. We have open hole logs, we have mud logging, we have sonic log, we have caliper log, we have SP, NMR, etc., etc., etc. SP, you see, spontaneous. Case hole also, you see, in the open hole before we do casing, and here after casing and cementing. Oil production phases, also we have primary, secondary, and tertiary. This one. Tertiary means EOR, enhanced oil recovery. We can pump polymer, you see polymer, surfactant, steam, hot water, like this one. So we have primary phase, secondary, tertiary. Here, this is very nice chart. We have primary recovery, either natural flow or artificially. Then we have secondary recovery. We need water flooding, pressure maintenance. With this one, we can recover 30% of the original oil in place. Here, 30 to 50, and tertiary, we need more money to invest in the EOR. Secondary, this is also water injection, gas injection, you see. Tertiary, this is the EOR. I think that you have good idea about EOR. We have thermal recovery, we have gas injection, we have chemical injection. You see, we inject the steam, it will reduce the viscosity, then we can produce via the oil producer well, this one. You see steam. In Kuwait, last month I was in Kuwait, there is a project consisting of 42 wells in Kuwait, North Kuwait. They inject steam to these 42 wells for 6 months, injecting only. Then they stop for 1 month, soaking time. Then they open the well, these wells, 42 wells, for 6 months. And then they can repeat this cycle. So 6 months inject steam to reduce the viscosity of the oil, 1 month for soaking time, and 6 months production. So this is steam flood. I give you this study case from Kuwait. You see, this is gas miscible, and we can, the gas or water can push or sweep the oil to the oil producer well, this one. This is surfactant, also polymer. We can inject gas in Abu Dhabi. We used the CO2 to increase the production by chasing the oil from this area to the oil producer and to the surface. We call it EOR. You see, CO2 and water. This one, CO2 and water combined. This also. Problems that can occur in the well. We may have scale. We may have hydrates, like ice hydrates. We have wax, and we have paraffin. And each one of them, I mentioned to you, how can you solve it? Scale. You see, scale will be like this one. It will reduce the ID of the tube. You see? Paraffin also. You see the paraffin like this one. This is sediment paraffin. You see? Asphaltene, or asphaltene that we use it to make the roads between cities, between industry. This one, you see, asphaltene. Study cases and problems. These happened with me, study cases. You can have a look at it, and you will benefit it also. You can stop the video and you can look at it, and if you have anything, you can utilize it. Here we have injection well to the producer well, and so on. In the separator, we can separate water and inject it again to here. Abandonment. What do we mean by abandonment? A well is said to reach an economic limit. What economic limit? It will not give anything. If we spend, for example, more money on it, and it will not give us this money that we spend, in this case, it is not economic. We call it economic limit. When its most efficient production rate does not cover the OPEX or operating expenses. In this case, when the economic limit is raised, the life of the well is shortened. In this case, as if a man has died. In this case, we have to bury him. And proven oil reserves are lost. There is no oil in the well. And the well becomes abandoned. Abandoned, finish. In this process, a tubing is removed. We remove the tubing from the well, and sections of wellbore are filled. We have 3 plugs of cement, one in the bottom, one in the middle, and one below the surface. Of concrete or cement to isolate the flow path between the gas and water zones from each other. The surface around the wellhead is then excavated. We level it. Leveling, make it as if before we drill the well. And the well, we remove the well also. The wellhead and casing are cut off. We remove them. I will show you what is the shape of it. A cap, we put cap and weld it, is welded in place and then buried. We bury it. As if man has died, we bury it. Look at it, you see, cement here, and cement here. Then the well is secure. Like this one, you will see it like this one. What is this one? Nothing. Okay? Now, in this case, we finished. Thank you, my friends. We spent 2 hours. I became tired a little bit. Let me drink a cup of water. Any question, anything?
Okay, guys, if you have any questions, you can open your mic or just
Yeah, Miss
put
Mariam.
them.
Miss Mariam, she's asking,
Yes.
how can we determine the type of injector well? So normally 90% of the injectors will be water. 90% will be water. But if you prove, or the reservoir engineer advises that only water will not give the efficiency, the required efficiency, then he may combine it with CO2, for example, with polymer or WAG, 6 months gas and 6 months water. But normally we use the water. Okay? This is the type of the injector. Clear, Ms. Maria? The water will not affect our oil. How? What do you mean? It is the most efficient material that can, or fluid that we use in our wells worldwide, not only in Algeria. Yes, Miss Mariam. Good. Thank you. Another question, please. Thank you, Miss Mariam.
Actually, a question. When we said that we have 3 types of drilling, we said we have horizontal and vertical and deviated.
Exactly.
What are when we use deviated drilling?
Yes. We use it. For example, you have city and you cannot remove this city, or you don't want to destroy this city and build a well inside it. So in this case, the city is here. City is here. We bring the rig and make like this. Okay, you imagine?
Okay. Yes.
Or relief well. If the well is flowing here, there is fire there like this. We make like this relief well and pump heavy mud.
Okay. Thank you.
Thank you.
And for a question, if when we do a drilling, we have how to ensure that we don't have an evasion of any other fluids, like when we do the production.
You have logging, you have open log. I told you, when you drill the well, you straight away, you have to make logging. This log will give you the reservoir saturation from water, oil, gas, the gas oil contact, water oil contact. All of them will give you with the log. Depending on it, you have to decide the way forward.
And my last question is for the Christmas tree. We said that it's responsible of the production. When we do the production, we use the Christmas tree. So when we product, is it responsible also for the separation of the gas and oil?
Yeah, oil, water, gas, all of them. We can control all of them, either for producing or for injecting.
So it's
two ways. Okay. For oil producing, gas producing, water producing. Also for injecting, gas injecting and water injecting.
Okay, and why do we use different types of Christmas trees? Like, why don't we just use one type? Like, what's the difference between all?
This is good question. I explained that to you, but I will repeat it again. I told you, if we have oil well with medium pressure, we use conventional. You remember this, what I told you?
Yes, yes.
But if we have high pressure gas well, we use, what do we call it? The
monoblock or something?
Monoblock, yes, exactly. You see, you didn't forget. Monoblock. When we have offshore, we use subsea, right? Subsea Christmas tree.
Yes.
So we have 3 types. Excellent. Good question, this one.
Guys, if you have any other questions, or we should end the session.
They are sleeping. They are sleeping, I think. Okay, thank you very much for all of you. I really enjoyed. I hope to see you again in another lecture. We spent 2 hours. It is very good. I hope I will send you the link to this lecture. You can share it with your guys and say hello to all of them. And I hope to see you soon in Algeria. Okay?
Yes, thank you, sir, for we hope to see you another time with another opportunity.
Sure. Okay? Thank you very much. Thank you. Goodbye.
Goodbye.